Hello, everyone. My name is Moria. I'm your presenter today. My current advisor is Dr. Nasrin. We are part of AIT. We do a lot of amazing work at AIT. We wanted to present one of our research questions that we're trying to solve here, which is personalized pedagogy through an LLM recommender system. So pedagogical design patterns. So as instructors and professors, we all know that we have faced several students within our class that doesn't pay enough attention or not uh, participate enough within a team environment or teamwork, and maybe not submit the assignments in time and procrastinate too much. These are all pedagogical design pattern problems that we face within the classroom. So as instructors, if we wanted to search for a problem that we have during class, it's really hard because these pedagogical design patterns, research has been done over the course of time. It's been dispersed all over the internet. And now how will we able to solve this problem? We wanted to propose a system that a instructor or professor can actually put in their problem, and the LLM will go ahead and search the solutions that are backed by research within the internet and also a knowledge base that we're building behind the screen. So that is the whole idea here. How would we do that? We do that with a RAG-based implementation. RAG stands for Retrieval Augmented Generation. It goes to three different phases. One is indexing, the second part is retrieval, and the third part is generation. So what happens in the indexing part is you have a knowledge base that you want to influence your LLM with, right? So LLMs cannot be influenced by your own data. How would we do it is you convert your data into vectors and you feed it into the model, and you do some prompt engineering on top of it, and then you retrieve the similar indexed knowledge base vectors from the database, and that's the retrieval process. And then you send in both the retrieval and the query that a professor is typing into the generation to get the response and influence the response based on the data that you have. So this is a research problem that we're trying to solve. We used RAG framework to solve it, and we developed our own model. And this is the showcase here. It goes through three different phases, and there's a lot of diagrams, vectors, and splits we have done on top of it. So let's go to results, right? So we have developed this model, and we wanted to know whether it's really impactful. So how would we do it? We have done both qualitative and quantitative analysis on our research and how we have done manual evaluation. We have requested 16 professionals, academic professionals from Kansas State to evaluate the responses generated by the LLM. We have picked 9 different queries, and we have sent all of the 9 queries into the model. And these responses are shared with these people, academic professionals, and they have evaluated on a scale of Likert scale, which is moderate relevant, relevant, or highly relevant, or not relevant at all. So we have seen very positive outcomes from there. A lot of responses that the LLM has generated has uh, really positive outcomes. A lot of people thought that this is a really relevant solution for the problem that we're sending. And we have also used some LLM-based evaluation. As you guys know, LLMs are known for hallucination and biasness. So we need to make sure that these are also measured. So we use GSCOT framework to evaluate the model for biasness and hallucination. Out of the 21 sessions we have evaluated, 3 sessions showed a little bit of bias and biasness within the responses and hallucination. So overall, the result looks really great. We were able to take one step forward to or closer to what we wanted to achieve, and we're very excited to share the problem with the world. And yeah, thank you for stopping.